Greenhouse warming theory is rapidly becoming the most expensive mistake ever made in the history of science. Video 8. Global temperatures can only be increased by absorbing radiation from a hotter body. Solar radiation heats our world and makes it visible. When solar radiation is passed through a prism, we observe that white sunlight contains a rainbow of colors. Scientists measure each shade of visible color as a unique frequency of oscillation, ranging from deep red at 405 terahertz to violet at 790 terahertz. Terahertz means 1 trillion cycles per second. All of these frequencies are observed to coexist independently in sunlight. There is no physical way for these frequencies of oscillations of the bonds and matter that are emitting the radiation to interact with each other in air and in space. Extensive laboratory studies of radiation in the latter part of the 19th century extended the measured spectrum down into infrared frequencies, meaning below red, that are not visible and make us feel warm, and up into ultraviolet frequencies, meaning extreme violet, that are also not visible but are so energetic, so hot, that they cause sunburn, cataracts, depression of the immune system, and genetic damage that can lead to skin cancer and mutations. In 1900, Max Planck, one of the fathers of modern physics, was able to devise an equation by trial and error, now known as Planck's law. Planck's law, shown here, calculates the observed amplitude of oscillation at each and every frequency of oscillation as a function of the temperature of the radiating body shown in this plot. We perceive amplitude of oscillation as the brightness or intensity at each frequency coexisting in this broad spectrum of radiation. Note that Earth is observed to emit only the frequencies at the amplitude shown in green, and as we all know, does not emit any visible light. A typical incandescent light bulb, on the other hand, emits only the frequencies at the amplitude shown in green and yellow, while sun emits all the frequencies at the amplitude shown in green, yellow, and red. The most important observations from this plot are that for a higher temperature of the body, first, the amplitude of oscillation radiated at each and every frequency of oscillation is higher. Second, the frequencies with the greatest amplitudes of oscillation are higher. And third, the brighter or more intense the radiation appears. But what is oscillating? All the bonds that hold the atoms of matter together are observed not to be rigid. These bonds are observed to oscillate between electrodynamic forces of attraction and of repulsion, very rapidly changing their tiny lengths. Each molecule scale frictionless oscillator on the surface of a body of matter transmits, through motion of charge, its single frequency of oscillation. This is precisely the way a radio antenna transmits its station's assigned frequency. This myriad of oscillators transmits a broad spectrum of frequencies of oscillation, all of which independently coexist and do not interact with each other in air and space in any way, except when in the immediate presence of matter. Planck's law, therefore, not only shows us all the frequencies at all the amplitudes of oscillation contained within radiation from a body of matter at a given temperature, but also all the frequencies at their amplitudes of oscillation occurring on the surface and within the radiating body of matter. In this way, Planck's law shows us the broad spectrum of frequencies and their amplitudes of oscillation that must be physically happening within a body of matter for that body of matter to possess a given temperature. What is extremely important here is that Planck's law, which simply describes extensive observations of nature, shows us that the only physical way to increase the temperature of a body of matter absorbing radiation is if that radiation is emitted by a hotter body that contains higher amplitudes of oscillation at each and every frequency of oscillation. The temperature of matter is not raised by absorbing an increased amount of radiation, as widely assumed. The temperature of a body of matter is raised only by absorbing radiation from a hotter body. The greater the temperature difference, the greater the flux of heat, the greater the warming. Greenhouse warming theory, however, assumes that temperature is increased by increasing the amount of radiation absorbed. There is no amount of radiation from Earth that can make any absorbing body warmer than Earth. Earth can only be warmed by absorbing radiation from a nearby body that is hotter than Earth, which in our solar system is limited to Sun. Planck's law shows us unambiguously that Earth can only be warmed physically by increases in the amplitudes of some or all of the solar frequencies of radiation reaching Earth. Greenhouse gases absorbing radiation from Earth cannot in any way make Earth warmer. It is physically impossible for a body to be warmed by its own radiation. There is a way in which solar radiation reaching Earth is observed to be increased. Most solar ultraviolet B radiation is observed to be absorbed by ozone in the ozone layer, warming the ozone layer. When there is less ozone in the ozone layer, in other words, when ozone is depleted, the greater amplitudes of oscillation of ultraviolet B radiation are observed to reach Earth, causing warming of Earth's surface and cooling of the ozone layer. Thank you.